as a, again, just because it helped them?
Yeah.
Okay, I'm glad then. So, the very first day of radicals, part 1, we went through a really long lesson to try to talk through like how to add them, how to multiply, how to divide, how to simplify. All of those skills can be useful in solving. Because really, in order to solve a radical equation, you only have to do one thing. You have to square both sides. But I mean, I make it sound so easy, right? Like, oh yeah, just square both sides. But like, the skills are being able to work around that. How do you get to the point before you square both sides? What do you do after you square both sides? Does that make sense? So here are a list of things that could be necessary. Like it may be necessary to incorporate some of these skills. It may not, but here's some examples. So reducing the radicand. What does that mean? Okay, so let's say I gave you root 40. Is that reduced? No, that's 2 root 10. Are you guys okay with how I just made that 2 root 10? Can you follow that? Okay, if you can't, let me know. But at some point, I'm not going to actually go through the steps of showing every single little thing there. So, expanding radical expressions. So that might involve like a root 2 plus a root 7 multiplied by a root 3 plus a root 8 or something like that. You actually got to like FOIL the thing. That could be a skill you need. Do you guys remember what multiplying by the conjugate was?
It was like the opposite,
When you're dividing, the way we solve a dividing question is by multiplying by what's called a conjugate. It's the opposite. So let's say I gave you 2 over root 7 plus 1. What you do is you multiply by root 7 minus 1 over root 7 minus 1. That's called a conjugate. And that's how we deal with dividing sometimes. And working with fraction exponents. If I give you x to the 1/2, that's the same thing as the square root of x. So you may need these skills. You may not. This is why I'm only doing this for dash 1. Because like these are the, like I said, these are the most tricky questions I can think of. But I'm designing them to try to make a point. So let's try. So start off actually with a pretty simple one. Believe it or not, simple. How do you deal with square roots? Square both sides. Is there anything impeding our chances of squaring both sides at this point? No. I mean, if I want to square both sides, why not? Square this, square that. So you're going to get negative 9x on this side. But that 3x plus 1, we actually have to like FOIL it. So don't miss that part. Hey, look, our square root's gone. Yay. Now how do you solve? FOIL it. FOIL it. So you get negative 9x. You get 9x squared. You're going to get 3x a couple of times, and you're going to get a 1. Now what do you do? Combine like terms, but I'm going to do 2 things at once, if that's okay. It's a quadratic. How do you solve a quadratic? Make it equal to 0. So I'm going to add 9x to both sides while I'm at it. So 0 is going to equal 9x squared, 15, and 1. At this point here, how do we solve? You have 2 options. I hear them both. You could factor or you could quadratic formula. Just depends on whether you can factor or not. So we're looking for numbers that add to give 9, and numbers, no, that's not right. Good catch. Add to give 15 and multiply to give 9. I like to focus on the multiply. There's not a lot of ways to multiply to give 9. There's 1 and 9, 3 and 3, and none of those are going to add to 15. Quadratic formula it is. Yay. Negative 15 plus or minus the square root of 15 squared minus 4 times 9 times 1 all over 2 times 9. Just clean it up a little bit now. It'll be minus 15 plus or minus the square root of a number. Get my calculator. I think it's 225 minus 36. I got 189 under the square root sign. Anybody else get 189?
Yeah.
And that's all over 18. How many answers do we have? Typically we have 2 answers. Is that done? The only thing you have to double check is make sure that that root 189 can't be simplified a little bit. So like divide it by 4, divide it by 9, divide it by 16, divide it by 25. Look for a perfect square number that can actually go into 189. 9 does. Good catch, whoever noticed that. So then we should write it as root minus 15. Let's see. I guess if it was a 9, I got 9 and 21. So that makes it minus 15 plus or minus 3 root 21 all over 18. Oh, that's not 21, that's 20. Okay, minus 15 plus or minus 3 root 21 all over 18. Are we done? Well, this is what x equals. Those are numbers. There's a reason why I picked this particular one, though. So the point I want to make on this one here is that actually we're not done. It has to do with simplifying fractions. The 21 is actually stuck, because the only thing that times this to give 21 is 3 and 7. It has to do with the fact that this number here is a 3, this one's 15, and this one's 8. Is anybody picking up on what I'm suggesting here? They're all divisible by 3. We can actually reduce this as a fraction, which is kind of the last step. Okay. What can end up happening here is because the 15 is divisible by 3, I can make it a minus 5. Because the 3 is divisible by 3, I can make it a 1. I'm actually going to write the 1, but if you skip the 1, that's fine. And because the 18 is divisible by 3, it becomes a 6. Okay, did that make sense, or should I go through a little bit about what was happening there? Okay, so it's pretty rare that that's going to occur. That's the reason why I wanted to show you this example. It's only going to be once in a blue moon that occurs, because it's 3 numbers you need. More than that even. You need to have this number right here, the square root number. It actually has to simplify. That's the first requirement. If that makes sense. The second requirement is that this number here, and that number here, they all have to be divisible by the same number.
So it's like 3 and 18 are divisible by 3, but 15 wasn't?
Then we're still stuck.
Then it's just that.
It's still stuck.
21.
Yeah. Does that make sense?
Yes.
We're good on that step? So the reason why I did this example then, if, like this is the whole purpose behind it, if all divisible, then make sure you reduce. Okay, let's try another example here. What the heck is going on here? Well, there's a 1/2 right here. So that just means it's a square root. Right, now you have a couple of options for how to isolate the square root. There is one obvious way of solving that I think most of you might pick up on right away. To get rid of this over 2, times the 2 to the other side. However, I want to suggest an alternate method. But does that make sense what I suggested at first, though? You could take this 2, times it up there. Here is another trick that might be useful. Do you guys see how the 4 and the 8 can be factored? So I'm just going to work with just that 4x plus 8. That could be 4x plus 2. Why is 4 useful when talking about square roots? Because 4 does square root. That makes sense? I could write this little bit right here. I'm just going to make sure it's clear. I could write this bit as square root of 4 next to x plus 2. But isn't the square root of 4 actually 2? So I could write it as 2 square root of x plus 2 over 2. Why was that useful? Well, rather than getting rid of the 2 on the bottom of the fraction by timesing it to the other side, today one of the goals I've already started with is, look, you have a 2 up top, you have a 2 on the bottom. They cancel. Let me make sure everybody caught that. So, yes, you could times this 2 to the other side. But totally valid. If you wanted to solve that, you're not wrong. But the reason why I made this example was for this trick. The 4x plus 8 can actually factor to 4 bracket x plus 2. The only reason that's useful, though, is the 4 out front can actually square root. If it had been a 5, that's not helpful. That makes sense. But because it was a 4, the 4 actually square roots to a 2, and lo and behold, that 2 and that 2 cancel. All right, so now square both sides. Square that bit, square that bit. You're left with x plus 2. And can I go straight to there? Can you guys follow that if I write it like that? Or should I show the in-between step? I guess I could show the in-between step if you needed. Just make sure that you actually like foil the thing. But if you can do that in your head, I'm okay if you skip that step. How do you solve? Okay, so 0 is going to equal x squared minus 7x plus 7. Is that right? I don't think this factors. But would it be okay at this point here, just to save time, if I just said use quadratic formula? And you guys would be capable of doing that? Because I don't need to take all the time in the world to use the quadratic formula, so I'll just say use quadratic. On a test, though, actually use the quadratic formula unless I tell you you can skip it. So the reason why I wanted to show you this one was for the trick that we played right here. Sometimes in dealing with that fraction, it may be better to factor. The factor happens to be a square rootable number, and then we can actually pull the square root out. That could be useful.
So when you took 4x plus 8 to get 4 and then the x plus 2 brackets, can you just divide everything by 4? So
Well,
when 4 was outside of the bracket?
No, because 4 can actually square root.
No, I know, but
Okay.
I mean the other step. To get it into 4.
Oh, to get it from here, I just factored. Yeah, basically divide out the 4, and it leaves you with x plus 2.
Okay.
Because if you refoil it back out, that's where the x plus 8 comes from. Does that work?
Yeah.
Okay. Any questions on that one? Okay, next example. You might get asked something like this. This one's not exactly yay. Any thoughts where we could start? Foil it, yeah, that's probably our best place to start. Let's try foiling it and see what we get. Okay, so good question. Let's re-go over the rules of foiling. So, first times first. So, 2 times 1 will give you 2. And then root x times root x would actually be root x squared. But maybe I could just make that, rather than square rooting x squared, I could just call it 2x. Would that make sense?
Yeah.
So that takes care of this first one. I'll do them in colors even if that helps. So that's purple. Let's do red now. 1 times minus 3 is just minus 3.
So we get rid of the square root sign?
Well, I think we might still have a square root sign with the other ones though. Like on the first one though, the square root sign is gone. Makes sense? Like the squaring and square rooting and x squared, that one gets rid of the square root sign. But like look what happens when I times these ones together. 2 and minus 3 can become minus 6. But there's a root x right here. And there's no root right here, so I guess I kind of keep that root x. It's just, I'm going to be stuck with it.
So you wouldn't have to put 3x with it, like it's just x.
The 3 times is by the 2. Like the outside numbers times by each other.
So then it's just like the square root, or like the root x is just times by 1.
Yes. Yeah, so it's almost like you're timesing by 1 there, if you wanted to write it times 1. Good. And then black. So that would be this one right here. You have a 1 and you have a root x. So you have 1 root x, I guess. I guess you could times 1 if you wanted, but that's kind of silly. I mean, you could write it, though. And that's all equal to 3x. So I'm going to stick with one color from now on, if that's okay. Any like terms? Yeah, those ones go together. So I could write this as 2x minus 3 minus 5 root x.
And then could you take it to x and bring it on the other side?
Fantastic. You're already starting to see some ideas here. So, Shelby, you're a little ahead. Is everyone okay with that up to there, though? Because you're totally right. I just don't want to go too fast. We still have a square root, which kind of sucks. So one of our goals is we got to isolate for the square root. So let's minus 2x from both sides. Let's add 3 to both sides. And what you'll have is minus 5 root x, and it's going to equal x plus 3. Okay, you've got a problem. You've got this minus 5 sitting out front. One of your options is to divide everything by minus 5. I don't like that option myself. The reason I don't like that option is that it's going to give you a fraction over here, and who likes fractions? I need you guys to know how to use fractions, but I also want you to be smart enough to realize that if there's a way to avoid a fraction, that's also being smart. That makes sense. So I did show you a trick yesterday. What did you say? Yeah, you can do that. You can throw that negative 5 inside the square root sign, so long as you throw it in there twice. So what is negative 5 times negative 5? 25. It's 25x now. That equals x plus 3. Now let's square. Yeah, now's the right time to square both sides. So I'll write it next to itself here, and square 25x will equal x squared plus 6x plus 9. 0 equals x squared minus 19x plus 9. And if it's okay with you guys at this point here, we'll just say use the quadratic formula. We know how. Does that make sense?
Yeah.
So in terms of purposes as to why I showed you this example, I think there's two main ones. One of them was to show you the idea of, well, don't be afraid of just foiling the stuff out. You need that skill. But maybe it's this one right here, the idea of that minus 5 right there. Rather than dividing everything by minus 5, which is valid, it will work, I would put it on the inside and make it a positive 25. It makes stuff a lot easier. And then hopefully you get to a point where you know how to solve from here, just don't make a mistake, I guess. So far, so good? Cool. Keep moving on. This guy right here. Not overly enjoyable. Because of the fact that you are now dividing by a square root.
Yeah.
So there is an option. One of your options is to take the bottom of this fraction right here and to fling it up over here and times like that. Not great, but it will work.
So then if you did that, would you?
We'd have to foil that. But I want to show you another trick. So, although that is doable, let me try another trick. I'm just going to make the equal to x plus 5 go way over here because I need some room to work with this side. Okay. One of the tricks I showed you was how to actually divide. And Jessica, you mentioned earlier, or at least you knew what I was talking about when I said multiply by a conjugate. What's a conjugate again then?
It would be the opposite. Like it would be that, but instead of a plus 2, it would be minus 2.
Perfect. So let's try that. Let's go x minus 4. On the bottom, we're still going to do x plus 2. That doesn't change. But the conjugate trick would be to times all of this by root x minus 2 over root x minus 2. That's the trick. Okay, well, what this means to do is FOIL. So we got a FOIL and we got a FOIL. But on the bottom is guaranteed to no longer have a square root sign. I guarantee it. I make you that assurance. So let's just work with the bottom. What happens when you take root x and you times by root x? It's just good old x. Because it is root x squared, but you could square root the x squared. So you just have x on the bottom. What happens when you take this 2 and you times by that minus 2 right there? -4. So this one and this one gives me this stuff here. Does that make sense?
Yeah.
What did you say, by the way? Okay. Fair enough. Okay, what about the other terms that you're supposed to FOIL? What is always going to happen to them?
Cancel.
Yeah, so don't even bother writing them. I mean, if you want to prove it to yourself, this will give you a 2 root x. This will give you a -2 root x. They'll cancel. Don't FOIL the top, by the way. You have x -4. And you have root x -2.
Oh, wow.
Ah. I heard someone have like a light bulb moment there.
Why don't you
My light bulb thinking.
Okay, so for someone who had a light bulb, can you explain why?
Because they're cancels the x -4.
Yeah. One of my goals today, if you haven't picked up on this, is whenever you have fractions, a nifty trick with fractions is find a way to cancel stuff in the same fraction. See how there's an x -4 right here and another x -4 on the bottom right here?
Boom.
Yeah, boom.
Done.
Okay, like we still have work to do, but hopefully you'd agree it made it a little bit better. Because now what's left is a root x -2 and an x +5. Fantastic. Add 2 to both sides. Root x equals x +7. Square both sides. Hopefully you kind of recognize the same steps. Slow me down, by the way, if I'm going too fast. Square both sides. X will equal x squared plus 14x plus 49. Put the x on the other side, and you would use the quadratic formula, but we're going to stop because why waste our time on that?
Oh, I put the 2.
So, I don't know, like the first example that you gave us, and we had, or the second example, no, wait. Yeah, the first example that you gave us, when we had to go and reduce everything. So when we use this quadratic formula,
Right.
how do we know
Whether we can reduce?
when we have to reduce stuff?
Okay, so you know how you got to this point right here?
Yeah.
Up until recently, I would have just said stop here. But now the 2 more things I want you to consider is, does that 189, can you actually like break it down further? And the answer was yes, we could. We made it a 3 and a 21.
Yeah.
And then the next question you got to ask is, are all 3 of these numbers divisible by the same number?
Okay.
And they were all divisible by 3, so then we could go even further. If either of those 2 things, though, the answer to that was no, we would stop.
With these other examples,
Yes.
we're just saying use the quadratic formula?
Yeah.
Like,
I would actually want you to use the quadratic formula still. I just, to save time today,
and then we just have to look and make sure that none of that are so.
does that work?
Yeah.
Okay. Okay.
7 times 7 equals
7?
79.
What you guys are just describing here, when you can learn to fix those mistakes, that's where you pick up probably most of the marks you lose. You probably discover is you do dumb stuff when you do math a lot, right? And it's like I facepalm a lot, where it's like I can't believe I missed that minus sign. When you get better at math, it's because you stop making dumb mistakes, I would say. So, I don't have a way of fixing that. Like, if I could find a way to hand you a bottle and say drink this and you won't make dumb mistakes, I'd be rich. But
Great. I like.
I might leave it closed. We've had a wasp problem today. If you want to, there's already 2 dead carcasses on the windowsill from grade 10 class. So. Yeah.
At least we put that together.
There's a fan.
Wait, what do I got left? 2 examples or 1 example? 2 examples. Okay, let's keep moving then. For this one right here, that trick that I played last time around where I multiply by the conjugate, I'll just let you know in advance. It actually won't help because it's not going to cancel with the stuff that was up top here. So I'm going to try a different trick this time. I'm going to multiply this stuff up to the other side over there. That's the trick I've got. So 2 plus root x is going to equal the root x plus 1. And we're bringing that root x minus 3 to the other side.
Well, we're doing it for 5x. Oh, that's
Sorry, root. So I'm bringing this guy up top over here, and I'm going to FOIL. So it's still 2 plus root x. Time to FOIL. Root x times root x is going to be x. Good. 1 times root x is just a single root x. Minus 3 times root x is minus 3 root x. And 1 and minus 3 is minus 3. Let me know if I lost you on that. Ideas? What can we do? Yeah, combine like terms. I'm going to recommend that we put all of our root x's all on the same side and all of our not root x's on the other side. Actually, this is kind of clever. There's a root x on both sides, so I'm just going to do that. So why don't I add 3 to both sides? That's a 3 over there. So that's a 5 here now. That makes that go away. And this x right here, I'm just going to subtract x. At this point here, this is a little different than you're used to looking at. Did I lose anybody in that step there? You're giving me a funny look. Where did I lose you?
The plus.
Sorry, that's a plus 3, by the way. So there was a minus 3 sitting over here. I added 3 to both sides to make that go away.
So should it be 5 plus x?
Well, for this x right here, I had to minus x to make it go away. Actually, that's the point I wanted to make on this one, though. Normally, it's not 5 minus x. It's usually like x minus 5. Does that make sense? So it's actually plus x minus 5. Or, yeah, like you just said, you can make it minus x plus 5. But the trick I want to show you is this. Okay? You're allowed, mathematically, to flip all of the signs if you change all of them. So this would be valid, making it a minus 5, a plus x, and a plus 3. What you're basically doing is you're flipping all of your signs by timesing by minus 1.
And what does that help?
Well, maybe it makes it look a little normal. Now I can make it x minus 5 rather than 5 minus x. I don't know that it helps a lot, but maybe it makes it more familiar. Because like right here, this 5 minus x seems odd compared to what you're used to. This trick here of flipping all of the signs around also means that there's a plus 3 rather than a minus 3. It's a good point. If you, it was, wasn't it? So we've got x minus 5 equals root 9x, because you've already figured out just throw the 3 inside. Square both sides. X squared minus 10x plus 25 equals 9x. Let me write this out here. You're squaring both sides. Because I put the 3 back under the square root sign, but when you put it under the square root sign, it's now 9. You're good? All right. Does it seem like at a certain point we're doing the same thing over and over again? Hopefully you can see why I teach things in the order I do. We had to start with we started with linear things, and then we did quadratics, and now we can do square roots because we've been at this point hopefully lots before. So hopefully you're getting to the point where you don't make mistakes because you know what to do. Just, minus 9x from both sides. X squared minus 19 plus 25. Use a quadratic formula, you're golden. Just don't screw up. I know that sounds so silly to say, right? But don't make dumb mistakes. Sorry, was that too fast? Is everyone okay with that one there?
I'm not.
Let me just leave that up there for a few seconds. By the way, one thing I do want to point out, when you guys do an assignment, if you'd like me to proofread your work for you, I will. Like, I've pre-marked people's assignments for them, where it's like, hey, look this over, see if you find a mistake. I won't guarantee that, I won't make a mistake, but I'll look it over for you. Does that make sense? And so if I see a mistake, I'll point it out. Please don't take that as meaning, if I don't find a mistake that it for sure is right, because I'm not looking it over in huge detail, but, if you want me to proofread for you, I will. Because often I can help you find the little mistakes you make where it goes, you missed a minus sign here, and you're like, oh, yeah, you're right. You know what I mean? So feel free to ask me that on a assignment. I won't do that on a quiz, though. You kind of have to do your own calculus, but I will totally for assignment. Okay, last one. Okay, so this one kind of has a few different tricks we can play. The first one is, what does the 1/2 mean? Well, it means you're square rooting. So it's the square root of x plus 1 over there. I have an idea for something we've already done before, though. This 2 right here, we could do that whole well, not the conjugate trick, but we can actually do the whole this trick. You guys remember that? Why is that useful?
It's going to be the better.
It cancels the bottom. What you're left with is 6x with a root 2. And on the bottom, you literally just have the number 2. Make sense? Because root 2 times root 2 on the bottom is just 2. But I've done this before. Why was that useful? With what? The 6. The 6 and the 2, they don't exactly cancel, but they reduce. 6 over 2 is 3. This is 3x root 2, and it equals root x plus 1. Now, this is not perfect, but I almost have it so that there's a square root on one side and a square root on the other side. And if I were to square both sides, I could just lift the square roots off and be done with them. The only problem is this stupid 3x. So why don't I put that on the inside? If I put the 3 on the inside, it would actually be a 9. But if I times it by 2, it would be an 18. And if I put an x on the inside, it would be an x squared. And I'm now to the point, this is kind of clever, where I have square roots on both sides. But all I have on both sides is square roots. So when I square both sides, all that really happens is the square roots come off. Make sense? And you're left with 18x squared and x plus 1. I don't even need to FOIL anything, which is kind of nice. Now, is this always going to be something you can do? No. But like in this case here, actually it didn't turn out too bad. So, let me just go through those steps again in case that was fast. The root 2 on the bottom, I times by root 2 over root 2, because root 2 times root 2 on the bottom literally gives me 2. The reason that's useful is that 6 and 2 actually divide by each other to give me 3. At this point here, I noticed, hey, I got square roots on both sides. I can almost just lift those square roots off. All I've got to do is get rid of this stupid 3x, so I did that by shoving it inside the square root sign. In doing so, now that there's square roots on both sides, I can just remove the square roots. It's now quadratic. Quadratic formula, you're done. So hopefully you can kind of see why I had these extra 6 examples. It wasn't something really new, but on every example I tried to show you some sort of little trick that you could use to solve the question. You don't always have to use these tricks, they'll come up rarely, but on some of them, like, it made the question look really hard, and it actually wasn't. Or at least wasn't as hard as you maybe thought it was. Okay, take a break as you need to. Rest of today, all of tomorrow, all of Thursday is work time.
Oh, really?
Can I have your assignment by the end of Thursday, please?
Wow. Okay.
Today's Tuesday. So you have like 2 full classes plus half a class to finish your assignment.
I'm going to go with question 5 today, Jamie. Jamie,
Okay, so
the question 5.
you don't know you're looking for numbers.
But I'm going to take my break right now before I start.
Those numbers two times. Goes into 8. 3 times 3 times 3. 27.
I'm pretty sure.
So 3 and 27. 27 will actually convert into. You just muted one anyways.
Sabrina Fraley, please come to the office for checkup.
The 27 gave an extra. It's kind of confusing because the other one is free. So the remaining
Love
bit is
here for the wolves of math.
Still a kid group. That doesn't change.